this video, we're gonna see double integral in polar coordinates. So, uh, before seeing this, in this, unlike simple double integration, not x y something something, here will come as a r and a theta. So in polar coordinates, we used to say the zero as a pole, and this is our axis. So just know it, r and a theta. We used to deal with the r and a theta. So now straight away we can go to the examples as we know double integration. So this is the first example. We have to differentiate r like a simple integration only, r dr. So with respect to r, it's nothing but r cube by 3, and upper limit minus lower limit, simple, blah 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 blah. These are simple, guys. This is equal, this is really easy. Some of the complicated problems like change into polar form and then evaluate. So that's what the very important thing as considered in this polar integration, polar double integration. So these are the important formula, but this formula is not needed, guys. Instead of this, you better use beta and gamma functions. There is a beta function in this form, like 0 to pi by 2 cos nx sin nx is equal to 1 by 2 beta of n plus 1 by 2 comma n plus 1 by 2. That beta function is there now. Use that beta function instead of this, and this is very important formula, guys. This is very important, just remember it. This is very important and very useful formula. Just look at it 2 to 3 seconds, and just a photographic memory, that's it. Just see it, just remember it, that's it. So now we have to evaluate over the area chordioid. So they told this as a chordioid, but how this chordioid is looking, it's a right sided chordia, left sided chordia, how this is actually in the graph. So there is a separate video for that. You just go to YouTube and search how to graph or how to trace a cardioid with the equation in polar form, something like that. You used to get it, because if I used to explain all the things in the same video, then it will go on hours and hours. So this is a given equation, this is a cardioid, and over area of a chordioid above the initial line. So this is an initial line. So above this is a pole. We have to start from the pole to the cardioid, which is nothing but the equation of the cardioid, which comes like the equation of cardioid. So 0 to equation of a cardioid and theta. As I told before, here we used to deal with the thetas and r's. So theta is 0 to 180, that is pi. So 0 to 180 theta, and r sin theta is nothing but given thing. And after that, a simple double integration, like doing this first, solving this first with respect to r, and then after that solving the whole thing with respect to theta. So simple self-explanatory steps. If you have any doubt in any steps, just comment below. I used to explain personally. Then you got the answer. And this is another question you have to elaborate. How are the boundary of a circle? R is equal to cos theta, R is equal to 4 cos theta. They gave simply circle. How do you know this circle where in a actual graph? Again the same thing. Just go to YouTube and just type how to trace a polar circle, how to trace a circle in polar form, something like that. You used to get it, because I can't explain everything in the same video, then it will go something cross the 1 hour or 1.5 hour. And then this circle is nothing but the smaller circle which is present here, and this circle is nothing but the bigger circle present here, and we need to find bounded between them in the sense this area is omitted, only this area is taken into account. So this area lower limit is the equation of smaller circle, upper limit is nothing but the equation of a higher circle, I mean bigger circle. So equation of smaller circle, bigger circle, and theta is minus pi by 2 to plus pi by 2. So from this to this, so minus pi by 2 plus pi by 2, and after that you know what is double integration, solving inside, blah 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 blah. You just look it up the steps, it's easy. And now in another question, where R is an area of a loop of a lemniscate. What the heck is lemniscate? How do I know what is lemniscate? So as you see, this is lemniscate, just learn it, this is lemniscate. But how you can graph it? in a as a rough graph, how you can graph it. This is r square is equal to a square cos 2 theta. If there is a sin 2 theta, then also it's a lemniscate. How that lemniscate looks like in a graph. So these are all you have to search in YouTube and or any other platform, and you have to learn separately, guys. There are many videos present there to how to trace lemniscate in a polar form. So just go through it. Until now, just learn it. This is a lemniscate and this is the picture of that. Some things you have to learn on your own. So searching and learning will stand a long time in your mind. If you everything getting easily, then you used to forget everything. So as we know, this is given and this is also given. So how do you find the theta for this? This is theta is by looking at this we can find it. How do you find theta for this? For this you have to substitute r is equal to 0. If you put r is equal to 0 at this point, what is that theta used to get? That's nothing but a theta of the lemniscate which ends at the pole. So if you put r is equal to 0, then a square will come this side as 0. So cos theta is equal to 0. Cos 90 is equal to 0. So 90 is equal to cos 90 is equal to cos 2 theta. So 2 theta is equal to 90. So theta is equal to pi by 4. That's it. Minus pi by 4 to plus pi by 4. So 0 to equation of a lemniscate. I mean r 0 to r is equal to a of root. So this square will goes as a root in this side. So they put it as a root of cos 2 theta. So 0 to r and theta minus pi by 4 to pi by 4. And these are simple steps of integration. Just look it up. If you have any doubt, comment below. Now change of the variable of double integration. This is very important as considered as a double polar form double integration. So how do we change? Let us see the principle behind this. So if this is a given equation, we have to change it into polar form. Polar form in the sense, instead of x and y, we should have r and theta. So what we have to do is we have to transform it. So dx dy will be transformed as du dv, and x is in any function u and v, and y is in any function of h of x u comma v, g of u comma v, h of u comma v, something like that. We have to transform it, and instead of dx dy we have Jacobian transformation, and that to determination of Jacobian transform into du dv, where j is dou x comma y dou u comma y. What does this mean? You used to get it by seeing this below steps. So this is actual principle behind this. So now come to our point, that is a polar. To change into anything into polar, so changing anything into polar, we are just putting x is equal to r cos theta, y is equal to r sin theta, and transformation from cos theta into polar, and then dx dy is equal to Jacobian dr d theta. Why dr d theta? Dr d theta nothing but the u and v, something like that. Okay, now to find the Jacobian, you use determinants, and that too dou x by dou r, dou x by dou theta, dou y by dou r, dou y by dou theta. This is the Jacobians. Uh, in some books they used to interchange this too, but it's not a problem. Everything will give same result. And after doing this, I mean differentiating with respect to r, differentiating with respect to theta. Do you know what is x-axis? Nothing but r cos theta. So doing blah blah blah, I used to get this, and you're putting in the equation dx dy is equal to r dr d theta. So here Jacobian operator will come, and that's nothing but your r. So r dr d theta. So this is the change of Cartesian double integral to the polar form. And now let's look up an example. So this is a given integral. We have to change it into polar form and hence evaluate this. So to change into a polar form, first look up the limits and draw the rough graph. This is the rough graph, and 0 to infinite, x is 0 to infinite, y is 0 to infinite. The whole first quadrant is taken, and you know what is x-axis? Nothing but r cos theta, y is r sin theta. So if you do that, you used to get r square, I think. So yeah, r square, and 0 to infinite, pole to infinite, so infinite pole to infinite. And what is theta? Theta is 0. This is 0, and this is a 90-degree one, so pi by 2, so pi by 2 r dr d theta. So instead of dx dy, r dr d theta will come. and e to the power minus r square. Now like putting by substitution method they solved this, so r square is equal to t, and then differentiating and then changing the limits, blah blah blah. Used to then finding the integration, double integration, first solving the inside integrals, the first integral and then second integral, and you used to get this. That's it. Now you have to hence evaluate this. How to evaluate this? Let's see. So we have this. So if we uh, if we simplify this, we used to get this. Why? How do we how we can separate this? Because the limits are same, so we can separate it. And after separating it, if you look up this, these two are equal. Why these two are equal? Just variable is different. If you integrate it also after applying the limits, because the limits are same, after applying the limits you used to get the same answer. That's why the two are same. So they are putting it up an x and they are squaring it up, and we know this is nothing but pi by 4 that we found before. So that pi by 4 square, the square will come as a root, and root pi by 2. That's the answer, hence we have evaluated it. In another question, by changing into polar coordinates, so first we have to take the limits. So y is equal to 0, y is equal to root of 2x minus x square, and we took it, we got the equation of a circle, and x is 0 to 2, x is 0 to 2, and this is 0 to the equation of a circle. And now we have to put x is equal to r cos theta, y is equal to r sin theta. If you put that, you used to get r is equal to 2 cos theta as an equation of a circle. So 0 to r, and theta is 0 to pi by 2, 90 degree. If you put a 0 to r is nothing but 2 cos theta, 0 to pi by 2. And what's inside this? This is nothing but, if you put x is equal to r cos theta, x square, x is equal to r cos theta, y is equal to r sin theta, and simplify this, you used to get this. And now simple double integration as usual. So now in another question, I change into polar coordinate, evaluate the integral this. So taking the limits, same as it is, same taking the limits, and graphing it, and then changing it to polar coordinates, putting x is equal to r cos theta, y is equal to r sin theta, then blah blah blah. You know this is actually simple like previous one, same as simple the previous one. You used to get this. At last the same thing, simple. Now this is another question to polar coordinates. So if you see, this is x is equal to y square by 4a. So it's look like a parabola, so just mark the parabola, and then parabola to x is equal to y. X is equal to y is this line. So in everything you have to put x is equal to r cos theta, y is equal to r sin theta, and to find the theta of this line, this is r cos theta is equal to r sin theta, r cancel, sin theta is equal to cos theta, when the theta will be equal pi by 4. That's it. So this angle is pi by 4, angle is pi by 4, and this is pi by 2. Up to this you have to find, that's why pi by 2, and this is pole, and this is the equation of parabola. So if you put everything and solve, and here an important formula will be used, just in this changing this x square minus y square, which is present here, changing it, cos square theta minus sin square theta will be present. Cos square theta minus sin square theta is equal to r square cos 2 theta. I mean, in the sense, cos square theta minus sin square theta is equal to cos 2 theta. This is cos 2 theta formula. And then for this you used to get these are simple steps. You just substitute x is equal to r cos theta and y is equal to r sin theta, you get everything, and 0 to the equation of a parabola, and theta is pi by 4 to pi by 2, and then as usual same solving procedures, same solving. These are all steps, guys. Don't look at speaker so it's tougher, something like that. It's a simple steps. If you don't know anything, just comment below, I will help you. And then another question, by changing into polar coordinate, same, you have to put you x is equal to r cos theta, y is equal to r sin theta. That's it, guys, everything got over. So if you find that by the limits it will be a circle and it's a first quadrant, because from 0 to it's going, from 0 to going, and the limits of y is 0 to a, so it comes around first quadrant. And in first quadrant 0 to the equation of a circle, if you put x is equal to r cos theta, y is equal to sin theta, and substitute r is equal to a used to get, so that's at 0 to r is nothing but a, and 0 to pi by 2, 0 to pi by 2. So if you solve, you get it. That's it. And next question, where R is a region bounded by semicircle. Okay, semicircle and an x-axis. Okay, an x-axis and a line y is equal to 0 and y is equal to a. If you plot everything in a rough graph, you used to get this. And after substituting r is equal to cos theta, x is equal to r cos theta, y is equal to r sin theta, you get this. It's a polar form of circle, polar equation of a circle. And theta 0 to pi by 2, self-explanatory. 0 to r is nothing but 2a cos theta. And simple solvations. That's it. And this is the exercise. Just take a screenshot or snapshot and just solve it there, so you get a better idea about this. So I'm just scrolling it. You just take a screenshot, and these are the answers for that. That's it. Bye. And it's, if this content is really helpful, guys, just hit the subscribe button. It's free. It's really free, guys. Please.